These, my ladies, are called woodlice. They live on dead and rotting foods, as you can see our pomegranates showing you there, and they also live in shaded areas, in very moist areas, because they need to make sure that they've got enough moisture to keep themselves working, because they rely on absorbing oxygen from the atmosphere, and they can't do that if they dry out. So we've got quite a few of these woodlice here. We're going to use them in the next or the latest PA core practical that you guys need to do. It's the CB8D core practical about respiration rates. Scientists carry out experiments to find out how respiration is affected by different factors such as space travel. They measure respiration using a respirometer, which measures the amount of oxygen used, the amount of carbon dioxide produced, or both. You're going to use, or I'm going to use, a simple respirometer. In this, you're going to be able to see if you can work, well, I can, work carefully with living organisms and make accurate measurements. So, what I'd like you to do is to read along with me as we carry out the procedure. We'll do it bit by bit so you can see what's actually done. So our first step is talking about collecting a tube with some soda lime in it that's held in place with some cotton wool. That's not actually been made for us, so we're going to actually make it soon. The reason we're doing this is the soda lime absorbs carbon dioxide from our boiling tube, which will hold our organisms. And the soda lime you need to know about is it's also corrosive, so you can't handle it with your fingers. So we use a spoon or a spatula to move it. And the cotton wool is there to protect me and the organisms that are actually going to be sat on top of it. Otherwise, the organisms will touch the soda lime, and that would be a bit disastrous for them as well. So what you need to do is get your boiling tube, okay? And you're going to put the soda lime in. You need about 2 to 3 centimetres of soda lime. As you can see, the soda lime is quite large chunks. It's obviously not massive, but rather chunky. And it means that there's lots of air that can get through the parts. If it was too fine, if it was more powdery, then the air wouldn't be able to travel around the parts very well, because the surface area would be high, but there wouldn't be no space. That's bad English. There wouldn't be any space, okay? So you just pour some in. I'm being very careful not to touch it. I'm doing it over the jar in case of any spillages. And now I have my soda lime. I'm just going to put a bit of my cotton wool, put it into the top, and using the other end of my spoon, just push it down into my tube. You don't want the cotton wool to be too packed in, or else again the oxygen and the CO2 won't move around enough. Okay, so now we're going to have a look at the collection of the woodlice. The woodlice, as I was saying before, they live in very damp, dark conditions, so they're a little bit stressed out about the fact that we've left the lid off for quite a while. But you just get your spoon, and then you can tap it ever so gently into the spoon. You collect your woodlice, and each time you do this, you'd use the same amount of woodlice, and you can just put them into a beaker or a weighing boat. Okay. So here are our woodlice that I've collected. So they're moving around. You can see they're clumped together. It's a behavioural adaptation that they have actually. They don't like being out exposed. They don't like being in the sunlight. And like I said before, they don't want to lose any water. So what they do is they clump together and they can reduce that. And the little guys that are underneath the top guys get to be in the dark as well. So now we're going to put our woodlice into our beaker that we've got. You pour them in very gently, but they may hold on to the sides of the beaker. They're good like that. And so now they're on top of the cotton wool, on top of the soda lime. And we will continue setting up the rest of the equipment, and we'll show you the finished product after that's done. So as we said before, we've got soda lime at the bottom of our boiling tube, and the job of soda lime is to absorb any CO2 that's being produced by our woodlice. Okay, so that means that the woodlice, whatever gas the woodlice is producing, that's more than what they are actually respiring in, is actually going to be absorbed by the soda lime. So what's going to happen along here is this red section, or this red fluid in our respirometer, is actually going to move according to how much oxygen our woodlice actually breathe in and then use for respiration. So what will happen is this red line, or this point of this red line, will actually move towards our boiling tube with our woodlice as they use the oxygen and remove it from the tube. So Mr. Ryan, could you please read for me the start value of our number?
So it's about 141 millimetres.
So we're at 141 millimetres. We need to note that down in our results table. We start with our start number, and then we're going to start the stop clock. And we hold the stop clock, we wait for the stop clock for 5 minutes. So we've now got to 5 minutes exactly. We're going to have a look and see where our red line has moved to. Where has it gone to, Mr. Ryan?
So we're just at 130 millimetres now.
130, and it started at?
141.
So the total distance that our red line has moved is?
11 millimetres.
Very good. Now what you would do is you would repeat this with a control, and the control would be exactly the same setup without any woodlice. And the reason you do that is you don't know whether the soda lime is removing more gas than it should be, but what will happen with the control is nothing. So you'll see no movement of the red line. So every time you use a control, it won't happen. You then repeat this experiment at other temperatures, and your teachers are going to give you the results that happened at different temperatures so that you can complete the work in the workbook. Good luck.